Hello, algebra students. Well, today we're looking at the quadratic formula again, and these will be problems that will have something more complicated under the radical, and we won't be able to just take the square root and be done with it because it's not going to be a perfect square under the radical this time. So let's look at this first one. Okay, and remember, we have to first have this in standard form, and this one is not. So we need to have 0 by itself on the right. So we're going to subtract 15 from both sides. And let's rewrite it right up here so we have a little bit more room. Well, no, then we might. I think it'll be better to write it down here. 2x squared plus 4x minus 15 equals 0. Okay, and I'm going to write the quadratic formula just once up here, and we won't copy it again each time. So here's the quadratic formula. Okay, so we'll look at our equation and identify A, B, and C so we can plug into this. So A is 2, B is 4, and C is negative 15. Okay, and we brought it over to the right side of the equation, so it's ready to go. So now we're going to plug into the equation. X equals, let's see, negative B. B is 4, so it's negative 4 plus or minus the square root of b squared, which is 4 squared that is, minus 4ac, and a is 2, and c is negative 15. Okay, and that's all over 2a, which is, a is 2, so 2a is 2 times 2. Here they are, a, b, and c, so I was just using those as I plugged in. Okay, so we just simplify this now. X equals negative 4 plus or minus. So what do we have under that radical? We got 16 minus, it's actually minus a negative. Let's go ahead and write this out. 16 minus a negative, so it's going to be plus, and this comes out to 120. Okay, and that's all over 4. Okay, so that's negative 4 plus or minus square root of, and what that adds up to is 136. Okay, so we've got to factor that and see what we have. That's over 4. But let's go ahead and factor that 136. We'll do it with this method. 136, we see what divides into it. We say 2. And then you got 68. And 2 divides into that. That leaves 34. 2 goes into that. And that leaves 17. So that's it. So we look for pairs, and we have one there. We can take a 2 outside that radical. So that's the only thing we're working on here, of course, is the radical itself. It was just the square root of 136, but now we take out a 2 times the square root of, and we look at, what's still in the radical. Okay, we took out the 2 because it was this pair right here. But what's still inside is a 2 and a 17. So 2 times 17 is 34. And that's the only thing inside. And that's it. Okay, and of course in the denominator, forgot to write down, we have 4. So now what you have to know about these is that by convention, by the common practice, we don't split these up when we have that radical there. That's not a perfect square that you can take like 144 or something. The square root of that's just 12, and you write it down and go from there. But when you can't do that, when you have this number here, like 34, for example, you just leave that in there, and you do not split it into 2 fractions. You leave it like this. Now, you do have to think about reducing, and the rule is the way this is usually done is what if something goes into all 3 of these numbers, then you go ahead and divide each of those by that number. Okay, but it has to go into all 3 or you just don't bother. So in this case, well, 2 goes into all 3, right? So we go ahead, divide everything by 2, and we're basically dividing the top and bottom of a fraction by the same thing. So you can do that. That is legal. So divide the negative 4 by 2, it leaves negative 2. 2 divided by 2 is just 1, so we have the square root of 34 by itself there, and then 4 divided by 2 is 2. And that's it. Okay. So you do reduce it if the same number divides into all 3 of the numbers, but you do not split this one. Okay, so that is our answer. X equals. Okay. So let's just look at a couple more of these. Okay. Okay, so actually this one we already have worked out. We'll just go ahead and look at it. So we have the quadratic formula here. We plug in for A, B, and C. We had to first put it in standard form, right? So we subtracted 5 from, subtracted 6 from both sides, and we're left with 0 on the right. Negative 11 is our C term, so there we have our A, B, and C right here. Okay. Now plug everything in, and you get this big thing here, and you can pause this, video to make sure you look at that and make sure it all makes sense, because it's a little faster since it's already written out. Okay, so it ends up under the radical 357. This is pretty sloppy. I'm gonna let's see, make that a little smaller. I'm gonna write this down again. Got too big a hurry there. So that's the square root of 357. Okay. And again, we leave it in this form. Notice that 357, we tried to factor it, and we just got 7, 3, and 17 as the prime factors, and there's no pairs. Okay, that's why it stays in the radical as 357. There are no pairs when you factor it, nothing to pull out. Okay, so everything is still in there. 7 times 3 times 17 just gets us back 357 again. So that's it. We cannot simplify the radical anymore. We look at our numbers and our three numbers, and this is a 1 out here, right? So it's important to realize that we would only reduce this if we have some number that divides into 7 and 14 and 1. Okay, it has to divide into all three of those, and there is nothing that does. Okay, so this stays like that. Okay, you don't have to write the 1 down there in there. I just wrote that to kind of make it clear that we can't reduce this. 7 goes into that and that, but 7 does not go into 1. Okay, so that's why we're done. Okay, so that's that one. Now we'll have to start a new page. So we're out of room for one more example. Okay, so here it is. Okay, example 3. Solve using the quadratic formula and here's this one. Okay, so the first thing we might notice is this one's already in standard form. Yay, we don't have to do anything before we start. So we'll just write down A, B, and C. A is 2, B is also 2, C is 11. And now we will plug everything into the quadratic formula. We can write it down real quick first. Okay, and so plug everything in. Okay, x equals negative b is negative 2 plus or minus square root of b squared. I'll write that as 2 squared. A minus 4 times a times c. 4 times a, which is 2, times c, which is 11. Okay, so, and that's all over, let's see, 2a, that's 2 times 2, because a is 2. Okay, so you got negative 2 plus or minus. Under this square root, we have 4 minus, let's see, that's 88, right? 8 times 11, 88. Okay, and that's all over 4. So what's going to happen here? We're going to get a negative under that radical, right? I knew it was going to happen sooner or later. 4 minus 88 is negative 84. So we have to simplify what's under that radical, right? So what we're going to do is we're going to realize that the square root of negative 84 equals square root of negative 1 times the square root of negative 84, or times the square root of 84, sorry. Okay, so there's going to be an I there, right? It's going to be I times the square root of 84. But of course, we have to see, well, what about this 84? Can we simplify that with our factoring? So let's see if we do. We're going to put 2 here, and that gives us 42. Go 2 again, 21, and that gives us 3 and 7. Okay? So that's our factoring. And so what do we do with that? Well, we got negative 2 plus or minus. Now, what comes out, of course, is 2, because there's a pair of 2's, but there's also an I out front. Okay, don't forget the I. We said this is I times the square root of 84. So we'll just write it down here, what we have then. I, and we brought out a 2, and inside we still have the 3 and the 7. Okay, 21, because you got to take 3 times 7. Okay, and you get 21. So we usually write that as 2i squared root of 21. And that is going in where the square root of negative 84 was, right here. It's plus or minus. We've simplified that to 2i times the square root of 21. Okay, and it's still over 4. Okay, so this time we do have something that divides into all 3 of those. We're not going to split it up. Why are we not going to split it up? Because this radical, whenever you have that, and there's a radical left that you can't do anything with except, display it in sort of a standard way. When we have that, the convention is we don't split this up, but we do try to divide something into all 3 numbers. Okay, so we have this, we have this, we have this, and obviously 2 goes into all of those. So divide each by 2. Negative 2 divided by 2 is negative 1. And then 2i divided by 2 just leaves I. We could put 1i there, but we don't have to. What's under the radical is 21, and underneath is just 2. Okay, because we divided that by 2, that by 2, and that by 2. Okay, and so that I think that's it. Okay, so that's all for today. We do have to be able to use those skills that we practiced as far as the radicals, right? Simplifying radicals and dealing with the imaginary number inside. That is, when you have a negative inside. inside the radical, the square root of that is going to be I. Okay, I is the square root of -1. Okay, well, thanks, and hopefully that helped. Thanks for watching. See you later.